So image processing is, to me, given a discrete image, image, for instance, you would take with your digital camera, right? You can save it in TIFF format. That becomes our input, right? So an array of numbers where the array is the pixels in the image, right, the grid, and in each pixel we have some number representing, for instance, the color in that pixel. And then there's image processing can be of many questions. For instance, one question is, how do I filter this image to improve its signal-to-noise ratio? Okay. So in that case, the output is another image. Or how can I divide this image into its parts? So for instance, if we have, instead of an image you took with your digital camera, maybe we have an image that comes from magnetic resonance imaging. You put somebody into the MRI scanner and take an image of their head. Now in there's different things we're going to see. We're going to see the brain, for instance, but we're also going to see the components of that brain. So how do we take that image and break it into its part, find where is the gray matter of the brain, where is the white matter of these components? So in a way, it's very much like digital signal processing. Right? It's digital, and it is a signal that we're processing, but we are specifically interested in these signals we call images, and they're either two-dimensional signals, for instance, if you're taking an image with your camera, or in the case of the magnetic resonance image, it's a three-dimensional signal, right? Because it's a 3D volume we're looking at. So it's multi-dimensional signal processing in its essence.
Okay. And like from